Hi everyone. So I want to start with, I want to clear the confusion for the people who came to the room just now. If you wanted to watch Jose's talk, that already happened. I got confused myself. I wanted to keep his speaking slot. But yeah, this is a talk about telemetry. But yeah, you're welcome to stay here and listen to it. So Telemetry is a new open source Elixir project. The goal here is to improve and standardize how we instrument and monitor applications running on the Beam. So the project started off as an Elixir project, but now we're also trying to make things useful for basically any language running on the Beam. So telemetry is important, and monitoring is important for a couple of reasons. So imagine that you write your application and you run some tests for that application locally. You get all the green dots from XUnit. We all love them. And these tests allow you to verify that your application works correctly when it comes to logic. So you're sure that you're not violating any business constraints. You're sure that it's working according to some requirements. So we're fine with our logic being correct, and we happily deploy our application to production. And all goes well until our servers go on fire, and the only way we get to know about it is an angry email from our customer. This is not good. In cases like that, we usually wish we had something which would tell us that something is going to get wrong, that something which would tell us that our application is going to crash. Or if not that, at least we'd like to know why it crashed after the fact. So this is what monitoring is for. Some people like to joke, or maybe not even joke, that they only test in production, that they don't test locally. But in fact, when we deploy our applications, we all test in production, because our development environment is nothing like production. And the only way to verify the performance of our application, its fault tolerance, resilience, is to deploy it out there and see for yourself. And without monitoring, we don't get any visibility into what's happening inside. It's also crucial when we want to improve the performance of our application. So without monitoring, we don't know that there are some performance issues in the first place, unless our customers complain. And without monitoring, we can't really tell if our application's performance improved when we change some code. So we know that monitoring is important, but even though we all know that, we still sometimes treat it as an afterthought. So as in the short story at the beginning, we wish that we had monitoring after the fact, after something went wrong, but we didn't apply these practices before. And it happens for some reason, but basically telemetry's goal is to move the moment when it starts to monitor our applications earlier in the life cycle in our project. So ideally our project will be monitored right after we, generate our new application using Mix New. So this seems like a quite logical step to do if we think about monitoring as another form of software verification. So in the past, we used to write tests very late in the project lifecycle, if at all. And now we test quite often because it doesn't make sense to write the code which doesn't work correctly. The same goes for deployment. In the past, we planned these huge releases. There were 20 people coordinating that effort. And these days, we deploy as soon as possible. We apply continuous delivery, continuous deployment practices so that we get feedback from our users that our application works correctly or that they like the features we've built. So telemetry tries to do the same for monitoring. Instead of monitoring after the fact or after we know that maybe something is going wrong, we should monitor early, and we should iterate on our monitoring practices to basically adjust them to our application. We can start with some defaults and always narrow it down to our specific application. So the question is how telemetry is going to do that. And I think it's easiest to answer this question if we go through the process of instrumenting example application. It might be an HTTP service. And let's see what are the pain points related to that these days. So in a web service, we need some function which would handle the request itself. It accepts some parameters related to the request, so host, path, method, headers, and body. Then we decode the body into a map, maybe. Maybe the body was the JSON or form parameters. And we invoke some business logic on that. And based on the result of that business logic, we either return a successful response to our client, or we return an error. Maybe user wasn't authorized to perform that specific action, or maybe parameters were simply incorrect. So for a web application, the first web metric we might apply to the system is number of requests we're accepting. That's pretty good first guess. Because it gives us an insight into what load we're handling at the moment. If something goes wrong, we can later correlate the issues with the number of requests we are handling. Later, we might instrument the successful response case. So in this example, we increment some counter. And we also give it the status code so that we get a distinct counter for distinct status codes returned by our application. So in this case, we are counting responses which returned status 200. And we can do exactly the same for the error case, so that if the error is returned, we can see how many of them were returned in some period of time. So later we might dive into our business logic, and maybe this part of our application's logic is really important to the company we're building this for. So they may want to track how many times this particular feature was used. So this is kind of a business metric to show management that this is indeed used at all. So later, the business logic does some usual stuff. So we authorize the user based on parameters. We maybe query the database. We might insert something or retrieve something from the database. And later, we might push an event to some message broker like Kafka or RabbitMQ. So pretty usual stuff. And later, if we go into each of those functions, so authorize, query the database, or push an event, we might track how many each of those were invoked. These are probably used in multiple parts of our system, so it's better to update those metrics here than scattered throughout the whole project. And what I like about these kinds of metrics is that they are all related to the load we are putting on external systems. So if we're authorizing the user using some external identity provider, we're querying the database or pushing an event to a message broker, we can see how big a load our application generates on other systems. So we have that. We have the first metric we defined for which shows us how big a load we are accepting. But it's also a pretty good idea to see how many resources our application is using at any given time. So we usually track, for example, memory used or CPU utilization, so that, for example, when something goes wrong, we can see that high memory usage is correlated with the number of requests we're handling. So maybe we can improve something in our code to account for that. So all of this code doesn't look that bad. It's just a couple lines of code here and there. But what I don't like about this code is that it's extremely repeatable if you're building multiple projects like that. So probably for every HTTP service we're building, we're probably going to define the same metrics, at least at the very beginning. So we track the number of requests handled, the number of errors and success responses returned. We do that at the beginning so that later we can narrow this down to some more interesting metrics about our application. What I personally also don't like about this kind of approach is that we're mixing concerns here. So in the code we had before, if we decide to add more metrics, we need to add a line of code for each of those. And this is coming from my experience on one of the projects I've worked on, where the actual code for which updated metrics, there was more code related to instrumentation in the function than the actual thing which the function was supposed to do. So in this case, we might have more lines of code related to metrics than handling the request itself. This introduces coupling between that code and our instrumentation code. I really like this quote from the book Release It, which sums it up pretty nicely, that our application code should not be intertwined with the monitoring. That monitoring and reporting should be built around our system, and our system should be only handling the thing it's supposed to do. So telemetry aims to solve both of these issues, and it's doing so by using the events. Okay, the white border here ruined the effect because the room was supposed to go dark when the slide goes up, but never mind. Let's continue. So we're using functional programming language. So the easiest thing we can do to abstract away this instrumentation code is to basically define a function which contains all of that. So in this case, we define a handle HTTP start function, which updates the same metrics we used to update when the request was started to being handled. And later, the only thing our request handling code needs to do is to somehow notify or somehow basically invoke this function so that these metrics are updated. And this is what core telemetry library is all about. It basically is about emitting events, so letting other parts of the system know that a thing happened. For example, we're handling HTTP request now, and attaching to those events some event handlers so that we can react to those events. So given the event handler before, which handled the HTTP start event, we attach it using telemetry like that. So we provide the handler ID, which needs to be unique in the whole system. We provide it with an event name. So we use some HTTP request start event here, and we give it a 4-argument function which handles that event when it's emitted. So this is about handling the events. We also need a method for emitting them. So telemetry has a function for that, which is called execute. And I know that it may sound misleading from the first look, because it's called execute and we're emitting events. But we chose this name because it really tells what the function does in fact. So in telemetry, the event handler, the events are not messages. We're not sending messages to some process, like in the case of gen event, but we're retrieving all event handlers attached to that event, and we're invoking those event handlers one by one synchronously in the process that is emitting an event. This basically provides some kind of back pressure on the whole system because we're not because there's not single process which is a bottleneck in handling the events, like with Gen event built into Erlang. So telemetry event consists of 3 parts. We have the event name, in this case my app HTTP request start. We have a map of measurements. So measurements are some measurable properties about the thing that happened. And the last argument is metadata. So metadata should describe the context of the event. And in this example, we might use a host and a method of the HTTP request. So we didn't choose to merge. At the beginning, we used to have a single map for measurements and metadata, but later we got feedback that it might be a bit confusing. So now they are split, and we have separate maps for both of them. So given telemetry, our previous code for handling the request might look like this. So instead of updating those metrics we used to have in place in those parts of code, we simply emit telemetry event. Okay, so you might ask, why don't we simply call the handler function here? Why don't we do that? We can't do that because it's our own code. And you would be right. It wouldn't make sense to build telemetry for those cases. But the thing is that we don't usually write our own functions for handling the request. We usually use some kind of framework like Phoenix or Plug. The same goes for other libraries. For interacting with database, we have Ecto, or for pushing messages to message brokers. We also don't write those libraries ourselves, usually. So the true power of telemetry is that if the libraries would emit events like that, we could simply attach to them and react to the events emitted by libraries. So if when Ecto emits an event, we update some metrics related to HTTP requests. When Ecto does the same, we update metrics related to database queries, and we can do the same for Phoenix. So let's take a look at what is the state of instrumenting libraries in the Elixir ecosystem with telemetry. So both Ecto and Phoenix, they used to have, they still have their own instrumentation frameworks. So Ecto has the Ecto logger, and Phoenix has its own instrumenters. But Ecto, since version 3.1, uses telemetry and basically favors telemetry over the Ecto logger. And Phoenix, since version 1.5, will come with telemetry events enabled by default. So we would be able to attach to them and use them instead of Phoenix instrumenters. We also have added telemetry integration to Plug. So since Plug 1.8, you are able to use Plug telemetry plug, which emits an event whenever it is invoked and right before the request is sent. So basically, you can monitor any Plug pipeline using that plug, including your Phoenix endpoint. So this covers the metrics related to HTTP databases, so basically stuff which libraries could provide us with. The other nice thing about this kind of design is that it can be used not only for metrics. For example, if your library is handling something automatically for you, like reconnecting to a message broker, and you would like to keep track of that, it could simply emit an event letting you know that that thing happened. So we also had this these metrics related to utilization of resources. This is tricky because there is really no library which does that for us, and it would be nice to use the same interface for these kinds of metrics and metrics related to the virtual machine. So for that, we have built Telemetry Polar. So Polar is simply a gen server which every couple of seconds takes some measurements from the VM, like memory used or the length of rank use, and emits those as telemetry events. These aren't really events when we think about them, but it's nice because we can use the same interface for all kinds of metrics in our application. So this is about emitting events, but the part that is repeatable, and we do that in our applications, is reacting to them somehow, so updating metrics, because we're not really interested in individual events emitted by some parts of our code base, but we want to aggregate them somehow. For example, we want to count the events, or we want to sum up some properties of the events. So for that, we have built another library, which is called Telemetry Metrics. It basically allows you to build definitions of metrics, which specify how telemetry events are aggregated over time. So the simplest metric is last value. It basically holds the value of the last event with the given name. So in this case, we are building a last value metric called VM memory total. And this definition also means that we're going to use a VM memory event. So this is an event emitted by Telemetry Polar, and that we're going to use a total measurement. Because we have a map of measurements, we need to choose which one we're going to use for the metric. So both event name and measurement are overridable using options, so you can name your metric completely differently, but by default it works like that, so it's easier to define these metrics. So we have a bunch of other metric types. We have sum for summing things up. We have counter for counting the number of events. And we have distribution, which is supposed to give you some insight into statistics about your data. For example, if we're tracking the duration of HTTP requests, we want to know average response time or some 99 percentile, stuff like that. So with telemetry metrics, we're not really aggregating these metrics ourselves, because we figured that different monitoring systems, they expect different behavior. For example, if you're using statsd, you're pretty much good if you simply forward every metric update to statsd. But if you're using Prometheus, it expects you to aggregate those metrics over time. So with telemetry metrics, we hope that reporters will do the bulk of work. So we basically define metrics you want. You put them inside the reporter, and the reporter should update those at runtime in a way that makes most sense for the application, for the monitoring system you're using. So this is all really nice. We have to look at all the APIs, but this is pretty much a walkthrough through the documentation. So let's see that in practice. Okay, that's not it. Sorry. So I've taken the application from the Phoenix book, Rumble. So this application is about watching videos. So basically, you can register users. You can register yourself as a user. You can upload videos, and other users can watch videos. I have converted the application to serve a JSON API, instrumented it with telemetry, and run a load test on it. So if we are to instrument our Phoenix app using telemetry, we need to add some dependencies. So let's take a look at those. We add telemetry poller for the VM metrics. We add telemetry metrics so that we can specify what kinds of metrics we want to track. And we also include a reporter which will send metrics to StatsD at runtime. So let's now take a look at the application module. So basically here we have all the usual stuff generated by Mix Phoenix New. We have the repo, we have endpoint, we have presence. But I have also added one bit here, which is Rumble metrics. And this module basically contains everything related to metrics across our application. So if you need to find out what kind of metrics you're tracking, you just go to that single module and you're good to go. So as you can see, we're building a list of metrics here. We have virtual machine metrics, we have metrics for HTTP, metrics for controllers, and our database queries. And as I said before, we take those, we put them inside the reporter, which should handle them at runtime. And that's it. It's supposed to work. So let's see what kinds of metrics we are tracking. When it comes to VM metrics, we choose to track total memory used by processes, ETS and binaries, and also the total rank queue lengths of our schedulers. This is a metric which gives you a pretty good overview of how much work is accumulated inside the VM, and you can use it to determine if your system is being overloaded. And so when the length of the rank queues is growing, you can be pretty much sure that at some point your clients will start to get timeouts. So for that application, I have also built a dashboard with those metrics. So here we have the same metrics related to memory gathered at runtime. We have the total memory. We have the memory used by broken down by the memory type. So there is binary memory at the bottom here. The light strip down here is the ETS memory. And the big red area is memory used by processes. So we can see that during that load test that I've run, memory used by processes was growing over time. So maybe we were spawning more and more processes to handle the load. So to understand that, we can view metrics related to HTTP. So these are defined here at the bottom. We have a counter which counts the number of requests. Under the hood is using the Rumble endpoint start event, which is emitted by a telemetry plug. We can take a quick look at that. Yep. And it's here. So you just plug telemetry inside your endpoint, and it emits events you can use to instrument the whole endpoint. It doesn't need to be a Phoenix endpoint. It can be any plug pipeline. So when we go back to the metric definitions, we also have the counter for the responses. It's defined here. We use the Rumble endpoint stop event, so that is emitted when the response is being sent. We also use a new thing here. So we use tags. Tags basically tells telemetry metrics that we want to have a different counter for a different set of tags. So in this example, we are using the status code so that we can see how many error responses and how many successful responses we have returned. We also have the tag values option here. Tag values basically because by default, the values for tags are taken straight from the event metadata. But if the metadata doesn't contain the keys we want to use for tags, we need to transform those before they are used for metrics. So the HTTP response tags function here, it basically takes a con, which is included in events emitted by a plug, and we return a map with status and the status code of the response. And finally, for HTTP, we track the response times. So we also use the same event as we used for counting the responses. We break this down by the response status. We also provide the tag values function. And the last thing we do here is we convert the time unit, because plug telemetry uses a native time unit, and when we report our metric, we want that to be in milliseconds for some reason. And we can do that providing telemetry metrics with a tuple, which tells it to convert the unit from native to milliseconds. All right, so at our dashboard here, this looks like this. So we have the counter of requests. Oh god, that font is really, really small here. We have the counter of responses. So the blue line here is the number of responses per second with status code 200. The yellow line here is status 201, and we also have the light blue line for 401 response code, which means that some clients are making requests, but they are not authenticated. So if we want to go deeper into that, we can take a look at metrics related to Phoenix controllers. So Phoenix doesn't come with telemetry instrumentation yet, but I'm using my fork of Phoenix here. For that, we're basically counting the number of calls to particular controllers and actions. So we take the Phoenix controller call start event emitted by Phoenix, and we say that we want to count those events, but we want them to be broken down by controller and by the action. And since Phoenix doesn't provide that with event metadata, we need to convert those just before updating the metric. And we also have the distribution of how much time it took to process specific controller call. And if we take a look at the graphs here, we have the controller calls broken down by the controller and action. So the red line here is our controller for listing videos. So this is probably the most popular feature of our application. And if we take a look at the response times, we can see that the biggest response time is for the session controller create, so the endpoint which allows the user to authenticate themselves or to obtain the token for further authentication. And finally, if we also feel like it's not enough, we need to go a bit deeper. Is that so we can check out the metrics related to database queries. So I'm using standard events emitted by Ecto. It's already in Ecto 3.1. So we're counting queries to specific tables, and we also build a distribution of how much time it took to make that query. And at the bottom here, we have graphs of these metrics. So this is the query count. And here we have the query time. So this is pretty good, in my opinion, without instrumenting any code at all, only with building those definitions. So it's like 89 lines of code. We got pretty good monitoring of our application. What I also like about this approach is that you can use the same code. You can use the same metric definitions for instrumenting your own code. So if you have some metrics related to the business logic, you can use them. You can use the same definitions for that. So I also want to discuss a future of telemetry. So that was pretty good, 80 lines of code or 90 lines of code for instrumenting the whole app. But the slow part of this process, so instrumenting early using this approach, is that I still needed to set up the stats.d daemon. I needed to build this dashboard, and this also takes time, so it might discourage you from monitoring early. So we're planning to do this one thing I'm really excited about. So in the future release of Phoenix, we're planning to host the basic metric dashboard ourselves. So when you start your Phoenix endpoint or you generate your Phoenix application, you get these metrics definitions, and the base metrics dashboard is served by your Phoenix endpoint, which is pretty good in my opinion. You basically don't need to set up any monitoring tools whatsoever to get insight into your application right after you start to build it. Regarding the community, so Telemetry is a set of free libraries, but they are really, really small. So there's not much code to write, but we won't be able to benefit from Telemetry at all if the libraries are not instrumented. So if you have a library and you feel like your users would benefit from some kind of monitoring data being exposed to them, please use Telemetry for that. Do not reinvent, or do not invent your own instrumentation framework around that, because it will serve the community to use the same approach for this kind of things. We would also love your feedback on Telemetry. So Telemetry core library is pretty much done. We don't plan to change it much in the future. And it is really, really small, so it's not that bad to pull that into your dependencies. But we'd love your feedback on Polar. So we're basically trying to figure out what metrics related to virtual machine would be most useful to all of us. And also, we'd love your feedback on metrics, because this is the most recent library, and we still need to polish it around the edges. And regarding adoption, so as you have seen, Phoenix, Ecto, and Plug are almost all of them are emitting telemetry events at this point. I also know that UpSignal and Neuralink instrumentation uses events emitted by Ecto now, so they already do that. I have also heard that some folks at Widmaps are testing telemetry in production, so they use it to instrument some part of their systems in production. And of course, we at Erlang Solutions are heavily investing in telemetry, and we plan to work on it in the future. So yeah, if you have a library, please use Telemetry for instrumentation. If you build your application, please use Telemetry for building your monitoring infrastructure, so that we can all benefit from this useful instrumentation data and from our systems being monitored early. Thank you.